All right, honors Geo, you asked for it, right? You chose honors, so we got these tough problems involving finding angle measures, and you got to justify, which I love. Okay, now notice the title of this said that the sum of a quadrilateral is 360. We haven't discussed that yet. A triangle three-sided is 180. You step up another side to four sides, now your angles are 360 together. And again, I got to use that in this proof, I think, right? So there's not just one way to go about this, but I'm going to try my best to try to piece this through. Okay. So in the diagram below, we have segment AB parallel to segment CD. So let's do some drawing, right? So it says we have segment AB parallel to CD. We have segment AD parallel to BC. And it says DE and FC are perpendicular. So there's your right angle box. ADG is 54 and DCG is 39. Okay. And we need to find the measure of angle B right here. So I think my end goal is to get these three angles and then subtract it from 360. Well, I do know that this one is also a right angle. This is CGE. You could use perpendicular lines, or you could use vertical angles. I'm going to use the fact that these are perpendicular lines, right? So because you have perpendicular lines, you have right angles. So this will be my first try. So I'm going to say that angle CGE equals 90. And that's because you have perpendicular lines. Let's see. Perpendicular lines. All right, great. So I got a right angle box there. Okay. Next, how am I going to go about getting these two other angles? Well, I know that this is also a right angle right there. So if I say that this is a right angle, then I can get this angle here because this is a triangle up here. Let me do this in red. So if I say that this is a right angle, then I can find this angle by using this triangle. And you might say, well, why are you using this triangle? Why do you care? Well, then I can say that this angle here, that big angle, and this angle here have to be supplementary because they are same side interior angles. So I'll be able to get what this angle is, this big angle, and I'll subtract it from 39. All right. Now, I'm not quite sure how the justification is going to go, but we'll see what it allows me to do. So let's go back to my red step. So first off, I want to say that this angle, it's called DGC, is a right angle. So DGC is also 90 because of perpendicular lines. Okay, so that's true. So now up here, to find this angle, we'll call it GDC. To find angle GDC, I'm going to use the fact that I have a triangle, and I know that two of the angles are 90 and 39. So 180 minus 90 minus 39. Again, use a graphing calculator. Use your brain. That's 129. 180 minus 129 is 51. I know that GDC is 51. And that's because the sum of the angles in a triangle is 180. All right, good. So now that I have that, somehow I can find this big green angle now because I have parallel lines cut by a transversal. These two angles, this big angle here and this big angle here, are same side interior angles, which means they have to be supplementary. They have to add to 180 because if lines are parallel, same side interior angles are supplementary. So I'm going to say that this big angle, DCB equals, and I'm going to do 180 minus, and then this is 54 plus 51. So whatever that sum is. So 54 and 51 is 105. So 180 minus 105 is 75. So I think as long as you're correct, you can say whatever you want to. So DCB is going to be 75, and that's because they are same side interior angles. Okay, so it says DCB does not have a same side interior angle, but the measure of that same side interior angle is not yet known. Oh, I see. So they want you to show what ADC is first. So again, so ADC, this angle here, is 54 and 101, 51, that's 105. So ADC is 105. So again, just listen to the words, and that's just by simple angle addition. Okay, so now once I have this, once I have that as 105, now I can say, okay, right here, 180 minus, oh, sorry, 180 minus 105. And that's 75. That is now DCB. DCB is 75 because of the same side interior angles. Awesome. So now that I have both uh, DCB, the large angle, and this smaller 39, now I'll change my color to orange maybe. Now I can find this angle using angle subtraction, right? 75 minus 39, that's 36. So this angle is 36. And I'll call that angle GCB. And that's angle subtraction postulate. Cool. Okay, so now the question is, how do I find E here? Okay, well, what we're going to do is we're going to use parallel lines. Let's see what color I have left. I have yellow left, maybe, or light blue. Let's do light blue. So to get uh, to get an angle down here, I'm going to know what this angle is right there. This angle is made by this parallel line and this transversal. This transversal also connects to that parallel line. And do you see this backward Z? If this is 51, this is going to be 51 because they're alternate interior angles. So I'm going to call this angle FEG. So angle FEG is also 51 because they're all alternate interior angles. Great. And now, why do I want that? Well, now using yellow, I have a linear pair. This angle I just identified as 51, and this third angle in this quadrilateral that I want, this angle right here, they're a linear pair. Sorry for this. Linear pairs, right? Oh, yellow's no good. Linear pairs add up to 180. So I can do 180 minus 51, and that's going to be 129. So I'll call this GEB. Angle GEB is 129. And that's because they're a linear pair. And now I have the three angles in this quadrilateral. I have a 90-degree angle, 129, and 36. We're going to do that the sum of the quadrilateral is 360. So we'll do 360 minus 129 minus 90 minus 36. And that will get me this angle B. So here we go. So we'll do 360 minus 129 minus 9 minus 36. 360 minus 129 minus 90 minus 36. And that is 105 degrees. And that should be what that angle is, 105 degrees. Okay, so that is angle B. And that is because the sum of the quadrilaterals of a sum of the angles of a quadrilateral. And we're done. Now I want to show you something real fast, and I'm going to take away. I'm going to take away some color, or maybe go back to blue. Oh, pink. I haven't used pink yet. So this relationship here between this angle and this angle being same side interior angles, I could have done the same thing here. I wasn't thinking, right? This angle is going to be 75. Is going to be the same side interior with this angle. So I wonder if we could have done it that way too, because I got that this was 75 right here. So I could have said, okay, these two angles are same side interior as well. So if this is 75, that's going to be 180 minus 75 is 105. But I wanted to show you the 4 angles in the quadrilateral idea. So I will click submit. Oh, goodness gracious. And you'll see that we get the right answer. But notice mine took 11 steps. Notice theirs was only going to take 5 because I bet you they do what I did, right? 39, ooh, 141. Okay. 75 there. And then look, and then same side triangle. So they did it that way. Okay. So again, there's many ways to do it, and I invite you to take a look at what they did. All right. Okay. So that's what those problems are like. Man, oh man. So I'm going to do one more video of a proof before I let you guys go.